Hello, second year, fourth semester. This is uh, this is a short discussion regarding the metamorphism that you had been known. Now, let me recapitulate that throughout the years you have known that what is Rayleigh number, what is Reynolds number, what is the idea of diffusion. You have also known about the Fick's law, which is the important parameter that predicts the diffusivity or the diffusions of the nutrients transfers in the mineral phases or in between mineral phases. You have also known about the term chemical potential. We have already discussed about the Gibbs free energy and the role of the chemical potential in determining the Gibbs free energy. Now, simply whenever we see a metamorphic rock, now what we observe is that we observe the textural features in them, as you have known about porphyroblasts or porphyroclasts or shear related myronitic fabrics, etc., etc. Sometimes it is bimbatitic in character. There are different types of metamorphism, like regional metamorphism, like contact metamorphism, etc., etc. You have also known that there are different variations of the metamorphic path. Sometimes the path might be clockwise, where a rock column or the texture which you were observing, that will show increment of pressure earlier than the increment of temperature, and that's why in pressure temperature space it will look a clockwise path. On the contrary, there are also anti-clockwise paths. Anti-clockwise paths which shows an anti-clockwise trajectory of the pressure temperature history of that particular rock. Now, anti-clockwise paths are very much preponderant in rift systems, because there are intrusions of the basaltic magma from beneath the crust, and as a result the temperature grows. But the rate at which the temperature grows, it is not as similar as a change of the pressure, and that's why the path is anti-clockwise. On the contrary, in collisional setups, the path is generally clockwise, because the rate of the increment of pressure is higher than the rate of increment of temperature and the recorded documentation of the mineralogical phases. Now, it is quite fascinating to see them, or it is quite fascinating to understand their history, because from the things we have learned till now, we can certainly tell that there is definitely a dependency of the rate, or the rate dependency of the minerals, as well as the rate of diffusions, that controls which we observe as the textures or the disequilibrium textures in metamorphic terrains. In most of the times, what we see or what we observe, as an example, corona texture, which can grow during the cooling of a terrain by the reaction of plagioclase and pyroxene generating garnet or some other mineralogical assemblage like breakdown of some phase. Now, these are actually the frozen metastable relics of the time during which the mass transfer process was going on, to be very precise. Now, the book you have been given to read, that has some sections which tells different stories of the regarding origin, stories of these textures. porphyroblast, corona, porphyroclast, shear zone, myelinite, etc., etc. Those textural features you will be very it will be very easy for you if you can go through the books like Philpotts and Winter and etc., etc. But I think Winter will be best. Now the question is that obviously while a magma or the basic magma chamber is being intruded below the crust, it will